This video we'll be looking at derivatives of various functions using the chain rule. Okay, so I'll be teaching you how to apply chain rule. So chain rule simply says that if you have a function like function y which depends on the variable x, and you also have a function u which depends on x but y depends on u as well, then you can apply chain rule and get a result something like this. So dy by du times du by dx. Okay, so the key thing is to understand what this u is in the problems which you solve. Now there are two ways in which you can solve the chain rule. One is using, of course, this rule directly. The other one is the indirect method of applying chain rule, that is more faster. Okay, so I'll be teaching you those two methods for the first few problems, and then slowly I'll be transitioning into those ways where we don't have to directly use the chain rule. Okay, so let's start with a very simple problem here, y equal to cos root x. Okay, now the key thing here to understand is that chain rule is applicable for composite functions. Okay, it is applicable for composite functions. Okay, now composite functions are functions where you have a function inside a function. Okay, so something like this. So here you have a function which is inside another function. All right, so function g of x is a function which is inside f. All right, and vice versa, you can also write something like this, where function f now is inside another function which is g. So we need to first identify what are these different functions which are there inside some function. All right, now let's have a look at that. Here you can see cos is one function, and then you can see a function of square root. All right, and if you notice here, this root x is a function inside cos. Okay, so this is the first step. You have to identify which function is inside whom. All right, now I will teach you two methods. As I said, the first method would be to apply chain rule directly, and the other one is the direct method without using the chain rule. Okay, so first let's look at how to apply chain rule. Now we need to first identify which function is inside whom. So here, as you can see, root x is a function inside cos. So I will say let root x be equal to u. Okay, so therefore now let's take the derivative of this. So differentiating u with respect to x. Okay, differentiating u with respect to x, you will get du by dx equal to 1 upon 2 root x. Okay, this is the standard result of root x. So we've got this, I'll just call this as 1. Now therefore you will have y equal to cos u. Correct? Now here, when you take the derivative of the function y, it is going to be with respect to u. There is no x here. Okay, so therefore differentiating with respect to u, so you will get therefore dy by du equal to, now derivative of cos is minus sine u. Okay, so I'll call this as 2. Now by chain rule, now you need to first state what the chain rule says. So it simply says that dy by dx is equal to dy by du times du by dx. Okay, so what is dy by du? It is minus sine u times, now what is du by dx? It is 1 upon 2 root x. So we just write that 1 upon 2 root x. Now you're not supposed to leave this u here, you'll have to resubstitute it. So therefore you'll get your final answer as minus sine root x upon 2 root x. Okay, so this is your result. So this is the derivative of y equal to cos root x. Now let's see how we can solve this problem without using the chain rule. Okay, some people call it as the direct rule. Okay, I mean, I don't know, I'm not really familiar with all these terms, but the way I see it, I'm not using chain rule directly. So we have y is equal to cos root x. Okay, now as I said, you have to identify which function is inside whom. Okay, so as you can see, root x is a function inside cos. All right, now root x is inside cos, therefore cos is the outer function, inner function is root x. So when you do this direct method, Okay, of course you'll have to write this statement differentiating with respect to x. You'll write dy by dx. When you do in this direct method, what you would actually do is you will take the outer function, take its derivative first. Okay, so what is the outer function here? Cos. Root x is inside cos, so the derivative of outer function is going to be sine root x. Okay, don't worry about this. You have to deal with the outer function only. So it is going to be minus sine root x. Now you multiply this term with the derivative of the inner function. Okay, so as I said, outer function is cos root x. Okay, root x is inside cos, so I took the derivative of that. It came as minus sine root x. The inner function is root x, so that derivative of that inner function, which is root x, will be 1 upon 2 root x. Okay, so you can just directly write this as dy by dx equal to minus sine root x upon 2 root x. Okay, so it's just two-step answer. I mean, this is a very simple question which I've taken, but I hope you understood. Now, as you can see, the answers are same. So no matter which method you use, you'll still get the same answer out of it. Okay, so now let's try another function just so that we can loosen ourselves. So what I will do is I will solve one more time using, I will again solve using chain rule. Another problem I'll solve using chain rule. After this I will teach you the direct method. Okay, because chain rule gets tedious when you have 2 to 3 functions inside another function, inside a bigger function. So it gets tedious at those moments. So there we'll have to use the direct method. Okay, so another problem I'll discuss where there is chain rule involved. Okay, so I'll say that let y equal to x square plus 4x minus 7. Okay, so I have a function like this. So let's try using chain rule first. So I'll say so here, before we begin with that, I'm sorry, you have to identify which function is inside which function. Okay, so here right now I can see the square root function and I can see this polynomial, which is a function. So this polynomial function is inside the square root function. Okay, so my outer function is square root function, inner function is the polynomial function. So you need to identify these outer and inner functions. So I'll substitute which function here? The inner function. So I'll say let u is equal to inner function, which is x square plus 4x minus 7. Okay, so you write here differentiating with respect to x, that you'll have to write, and then you'll write du by dx equal to 2x plus 4 minus derivative of 7 is going to be 0. Okay, so this is going to be your answer. So you call this as 1. Now you write therefore y will be equal to square root of u. Correct? Now you take the now you write here differentiating y with respect to u. So therefore you will get dy by du, which is equal to 1 upon 2 root u. Okay, so this is again a standard function which looks like root x. So derivative is going to be 1 upon 2 root x. In this case it is u. Now therefore by chain rule. Okay, so we'll apply chain rule here. So therefore dy by dx is going to be dy by du times du by dx. Okay, so I'll just continue on the other side. So here what is dy by du? It is 1 upon 2 root u. So dy by dx is equal to dy by du is 1 upon 2 root u times. Okay, now what is du by dx? Du by dx is 2x plus 4. Okay, so you bring the entire problem together, you resubstitute for u, you will get 2x plus 4 upon 2 root x square plus 4x minus 7. Okay, so this was using chain rule. Now let's try with the direct method. So y is equal to square root of x square plus 4x minus 7. So as I said, our outer function is square root sign, is the square root function, inner one is the polynomial. So as I said, you will first take the derivative of the outer function, then multiply that with the derivative of the inner function. So therefore this will become dy by dx equal to, now this is going to be derivative of outer function is square root. So it's going to be 1 upon 2 root x square plus 4x minus 7. So you will write that inner function as it is when you are taking the derivative of the outer function. Now you take the derivative of the inner function. The inner function is x square plus 4x minus 7. So derivative of that is going to be x square is 2x. Derivative of 4x is 4. Derivative of minus 7 is 0. So therefore you will get dy by dx is equal to 2x plus 4 upon under root 2 times under root x square plus 4x minus 7. So you can go ahead, take 2 common out, and then 2 and 2 will get cancelled after that. So you will get an answer as x plus 2 upon square root x square plus 4x minus 7. So I hope you understood how to apply chain rule and how to do it by the direct method. Now I will take up few problems where I am going to do everything now based upon the direct method. Okay, now I'll show you how chain rule becomes a little bit more tedious from now on. Okay, so I'll take this example. This will be a good start. So this is going to be e raised to 3x plus 2 plus 5. Okay, so here if you notice, the square root is one function. This entire term inside the square root is a function, and then you have this exponent which is a function by itself. Okay, so there are 3 functions here, where 3x plus 2 is inside the exponent function and the exponent function is inside the square root function. So here chain rule gets very tedious. So you'll have to substitute for 3x plus 2, then substitute for this term, and then you'll have to do it. So here chain rule becomes a very long process. So here we are going to employ our direct method. Our goal remains the same. You start with the steps remain the same. We start with the outer function, then you go inside. Okay, so differentiating y with respect to x, you will get dy by dx equal to derivative of the outer function. Identify that it is going to be the square root. So derivative of that is 1 upon 2 root e raised to 3x plus 2 plus 5. Okay, so this is not going to change. The inner functions you are going to write as it is. Now you go to the next inner function. The next inner function is e raised to 3x plus 2 plus 5. So what am I going to do of that? I'll take the derivative and multiply it with this. Okay, it's important that you put brackets. So now derivative of e raised to 3x plus 2 plus 5 is going to be, now just to give you a quick recap, derivative of e raised to nx was n times e raised to nx, correct? So dy by dx, this is just to show you y is equal to e raised to nx was n times e raised to nx. So this n, the coefficient of x, came down. So here we just need to be a little careful. Now here it's not just 3x, it is 3x plus 2. Okay, it is 3x plus 2. So here what I am going to do is I will simply take the derivative of this entire function. It is going to be we won't need these many brackets, so it's going to be e raised to 3x plus 2. Derivative of e raised to x is e raised to x, so this is not going to, nothing is going to happen to that function. But derivative of 5 is 0, so that is going to remain as it is. Alright, so I have taken the derivative of this. Many people get confused here. They simply write 3x plus 2 times e raised to 3x plus 2. That's not the case. Here it is simply nx, here it is 3x plus 2. It's in the form of nx plus 2. So you cannot put that n down. So we'll have to first simply take the derivative of this outer function. Now in this outer function you have another inner function which is 3x plus 2. So we take the derivative of that 3x plus 2 now. Now the derivative of 3x plus 2 will be multiplied to this entire thing. Let's do that. Derivative of 3x is simply 3. Derivative of 2 is 0. Okay, so therefore you will get dy by dx equal to, so in 2 steps you will get the answer out. So this is 3 times e raised to 3x plus 2 the whole upon 2 root e raised to 3x plus 2 plus 5. Alright, so that was our answer for this particular function. Okay, let's do another example. I think I have another 6 to 7 minutes more that I can spend here. Okay, let's take this. So tan cos sin x. Okay, so y equal to tan cos sin x. Now here it's clear that sin x is inside cos and cos is inside tan. Okay, so what is the outer function? Tan. Alright, and then you have the inner function which is cos, and cos is the outer function for sine. Alright, so as I said, take the derivative of the outer functions first. So therefore, differentiating y with respect to x, please write that statement. I'm not writing it just to save time. So derivative of tan, so this entire thing becomes x. So derivative of tan x is sec square x, correct? So it is going to be sec square x. For us is this entire bracket. So it is going to be cos sin x. Okay, remember derivative of tan x is sec square x, but here we have tan this square bracket, so derivative of that is going to be sec square the square bracket. Now let's take the derivative of the inner functions. Now in these inner functions, amongst the two, cos is the outer one compared to sine, so we take the derivative of cos first. That is going to be minus sine. Now derivative of cos x is minus sine x. For us, x is this entire bracket, so it's going to be sine x. Okay, so I hope you understood this. So cos is treating this as an angle. Alright, now we are left with the last function, which is sine. So remember, we've taken the derivative of tan, we've taken the derivative of cos. Let's take the derivative of sine. So derivative of sine x is going to be, we'll multiply that to this entire term, it's going to be cos x. Okay, so you can of course take out the brackets and write this a little bit more in a systematic way. So sec square cos sin x times cos x into so this minus sign will come out straight away here, sine of sin x. Alright, so this is how you do it directly. Alright, so I'll just take another problem, take a tougher one. Yes, so we can try this one out. Y equal to e raised to root x, let me see if I've got that correct, yeah, upon e raised to root x minus 1. Okay, now this is a problem which I have not scripted, but let's see. Okay, so let's take the derivative here. Now as I said, our plan remains same. Root x is inside this entire function, which is e raised to root x plus 1, and this is of the form u upon v, so we'll have to use the quotient rule first. Okay, so what in problems like these, you'll have to use the quotient rule first, where we'll take into account in this way. Okay, derivative of u upon v is going to be v times derivative of u minus u times derivative of v, the whole upon v square. Okay, so I hope you remember this quotient rule. The video of it was is put up in my channel. You can go ahead and check. So this is going to be u and v, correct? So let's write v first. So e raised to root x minus 1 times derivative of e raised to root x plus 1 minus e raised to root x plus 1 times derivative of e raised to root x minus 1, the whole upon e raised to root x minus 1 the whole square. Okay, so let's take the derivative here. So this expression is not going to get touched. Okay, now here we will take the derivative of this function, but after that we'll have to take the derivative of root x also, because root x is a function inside this. So let's take the derivative of outer function. So here derivative of e raised to root x is simply going to be e raised to root x, and derivative of 1 is 0. Now let's take the derivative of root x. That needs to be multiplied here itself. So it's going to be 1 upon 2 root x. Okay, minus, now here this function is not going to get touched. Same procedure we are going to employ here. So here derivative of e raised to root x minus 1, e raised to root x derivative is e raised to root x, and derivative of minus 1 is 0. Okay, now let's take the derivative of root x, that is 1 upon 2 root x, the whole upon e raised to root x minus 1 the whole square. Okay, so you can clear the mess up. As you can see, e raised to root x is common, 1 upon 2 root x is also common, so you can take it out. So this becomes e raised to root x upon 2 root x times e raised to root x minus 1 minus e raised to root x plus 1. Okay, the whole upon e raised to root x minus 1 the whole square. So this can be simply written as e raised to root x times e raised to root x minus 1 minus e raised to root x plus 1 the whole upon 2 root x times e raised to root x minus 1 the whole square. Okay, so I hope you got an idea of how to solve a problem like this where you have u upon v form. Let me see if I can get one product rule kind of a problem. Yes, I've found one. Okay, let's just see if I can wrap this up quickly. So we have y equal to log of tan cube x times sine 4x. Okay, so this is the of the product rule type. So again we have to identify the functions. You have log, tan and sine. Log is the outer function. So let's just see if we can take a derivative straight away here. So derivative of this entire function, now outer function is log, correct? So we'll first take that derivative. That is going to be 1 upon log x. Derivative of log x is 1 upon x. So here x is this entire square bracket, so that we'll write as it is, tan cube x times sine raised to 4x. Okay, now we'll have to take the derivative of the inner function. So derivative, this looks like u times v, correct? So derivative of u times v is u dv by dx plus v du by dx, correct? When you have y is equal to u times v, so let's treat this as u, let's treat this as v. So this is going to be tan cube x times derivative of sine raised to 4x, derivative of sine raised to 4x, okay, plus sine raised to 4x times derivative of tan cube x. Okay, so we are going to get the answer very shortly. So this is going to be tan cube x times sine raised to 4x. So now derivative of this, let's go to the first term. So the first term is going to be tan cube x times derivative of sine raised to 4x. Now here inner function, outer function is sine, inner function is raised to 4. So let's take the derivative of outer function first. Derivative of sine is going to be cos raised to 4x. Okay, cos raised to 4x. Now derivative of the actually speaking, you should have taken the derivative of the outer function. Outer function is raised to 4. So this is going to be I'm sorry, I made a mistake here. It's going to be 4 sine cube x. Yeah. So the outer function is this exponent which was there. The inner function therefore now is sine x. So we take that derivative, is going to be cos x plus, okay, same story here, sine raised to 4x. Now here as you can see it is tan cube x. So you take the derivative of this cube first, which is going to be 3 tan square x times derivative of tan x is sec square x. Okay, now this looks quite messy here. I hope you understood this. I made a mistake here. Two functions raised to the exponent function and the sine function. So exponent is the outer function. You take its derivative first and then the inner function. Alright, so now we'll just clear up the mess. This is going to be tan cube x 4 times then sine cube x cos x, okay, plus 3 times sine raised to 4x tan square x and